So the shadow question is a bit of a classic. A 2 metre person is walking away from a 4 metre tall lamp post. So let's go, there's your lamp post, and your lamp post is shining a light downwards, and it's just going over the top of your 2 metre person. So that's your person there. Your person is walking that way, directly away from the lamp post at 1 metre per second. So we've got to work out what that means. So let's just draw the whole triangle. Remember, the lamp post is fixed, it's stationary, it's connected to the ground right there. So if I label that little section as x in there, then dx dt is 1. I want to know how fast the tip of his shadow is moving, so let's look at that in red. Now the tip of his shadow is up here. We want it moving against the ground. The only thing that's connected to the ground is the lamp post. So I want to think of how fast that red dot is moving away from the stationary point there. So if I label that as S, then that will give me how fast the red dot is moving away from a stationary point, which is the speed over ground. So I really need to find ds dt, and I know dx dt is 1. So ds dt, I need a differential equation. So there needs to be a ds on top and a dt on bottom. And given that I've got a dx dt, clearly there's an x in there. So there's my dx and there's my dx. That will cancel out to give me that pattern. And this is the thing that I do not know. I know that's 1, and that's what I want to find. I need the relationship between s and x. So that's grade 9 similar triangles, big over small. So let's look at big over small. 4 on 2 equals big S on small. Now remember, small's up here. So small will be S minus X. And I've just got to simplify that. So that'll be 2S minus 2X. Let's get the S equals 2X. And I'm running out of room. ds dx equals 2. So ds dx is 2. dx dt is 1. Therefore, ds dt is 2 metres per second. That's how fast the shadow is moving across the ground, the tip of his shadow. There's another question to do with the shadow question, and it's got to do with how quickly the shadow is growing. So it's exactly the same sort of setup. We've got a 4 and a 2, but this time the length of the shadow, how fast is that length of the shadow growing? So clearly the length of the shadow goes out to the tip, but starts at the foot of the person. So I'm still going to label that x. So I've got a dx dt is 1, and I want to label just that smaller line segment S, because that's how fast the shadow is growing in size. And it's the same differential equation setup. So we need a ds and a dt. There's a dx on top, so there must be a dx on bottom. So I still need that ds dx, but the similar triangle setup is a little bit different. So big over small is 4 on 2. Big is s plus x, and small is s. S plus x, s equals x, so ds dx equals 1. So ds dx is 1, and dx dt is 1. What's 1 times 1? 1. So the shadow is growing at a rate of 1 metre per second. And that's the answer. That's all you really have to worry about. Let's just think about what our two answers combine to get. If I know that he's walking at 1 metre per second and this blue line is getting bigger at 1 metre per second, then that means that tip is going at 2 metres per second, which actually agrees with what we had in that last question. Anyway, it's sort of nice that agrees with each other, otherwise we've broken maths. Anyway, be careful in the shadow question. You've got to understand whether you're looking at the length, the tip of the shadow moving over ground where S is connected to the lamppost, or whether the question is about the length of the shadow where the shadow's between the foot of the person and the tip of the shadow. So just be careful.